Inheritance often involves overriding special methods. The example of a special method that we are familiar with is the initialization of an object method, the init. And these can be overridden, for example, when inheriting from a class. So if you're inheriting from cat and you want a leopard, in the init you can override it to add extra attributes which can be added at instantiation, even extra attributes in the body of the init that are now permanent parts of the leopard. Maybe something self.spots or self.spot number or something along those lines. So these special methods are also known as Thunder double underscore methods, and there's a number of them, and we're going to tackle in the following program one more, and that is called the str special method, and that can be used to print objects. So let's go and have a look at this in code. So in this video, we are going to look at overriding the special methods. We're going to first override the init, the creation method, the instantiation method, in one of the cats. So I think we can pick the leopard, and what we're going to do is essentially add some property that leopard has that's not universal to all cats. So the first thing that we want to do is basically define the init for the leopard, and you could even copy this line here. Now it is the next line that is very important, and that is where you can specify what part of this is inherited from the cat. So you can basically super dot, and this is a special sort of Python function, init double underscores, and here you basically pick which of these attributes do you want to be basically, made the same way as they're made for the cat. And in our case, I'll take all of them. Cool. So what this is going to do is, well, you're overriding the method, but right now everything's identical. So even if we play this, I believe the super has open close brackets there. Try that again. Yeah. So what happens when we play this is basically, hey, we are overriding the init with an identical copy of the init. So if you're overriding it, you want to add something. And I guess leopards are either spotted or not. Black leopards are called panthers, so we can just call it spotted and set that equals to true by default. But we're also going to have self.spotted. Now again, they're not going to change their spot, so we can make that like a protected variable equals to spotted. So when you create a leopard, you can just use these variables, and we are going to default that it's spotted. However, you can also add false. So let me just print leo.dict. So spotted is true, but if we basically set that to false, then spotted is going to be equal to false. There is also another little variable. I mean, the non-spotted leopards are usually black, but we're not going to play with that. I think this demonstrates the concept pretty well. So the next thing that I want to do is improve on this printing method here. Like leo.dict with dunder is going to give you this dictionary of attributes, but we could put that in a sentence form, and there's a special method called the str method, and that can basically return a nice long string which describes the object, and that's really very handy. So we can basically inherit that and override it. I haven't thought of what we would override about itself, but let's actually talk about cat. So they have mass, lifespan, and speed, and let's create this special str method, and I'm going to show you what it does. In fact, I can give you a little bit of a hint, right? So let's just say you want to print Leo, and it'll just say object at a memory location, right? Leopard object at this memory location. So after we create this special str method, this is going to print out a nicely formatted string that tells you about Leo. So let's get started. We're going to need to define it, and that's just double under str. And And generally, doesn't take any parameters. And now we need to return a value. So I'm going to use this F formatting style. I'm still relatively new to it. It's actually new in Python 3.6. So it's a new feature that I quite like because it's by far the most compact. So let's start talking about the cats. First of all, you'd want to say that the name of the object, whether that's a cat, a leopard, a cheetah, and the way you can access that would be to say the, and then we can put inside the curly braces, type, so that's object type, self dot name, dot double underscore name. So that should work. So on the next line, we can continue with F, and then maybe something about ways. So what can we do here? Self dot mass in kg, space or no space, kg. I think this is gonna need that. I'm still surprised. Yeah, now it's finally lined up. Okay, so let's actually, you know how we're printing Leo? Let's see if this is working. The leopard weighs, so we're gonna need a space. And the leopard is capitalized. So if I was to print Tommy, I'm sure it would say the cat capitalized Tommy. We can fix that. We can just put the string to lower. The cat weighs 5, the leopard weighs 90 kg. Cool. So we can just add dot lower to that. The cat weighs 5 kg, the leopard weighs 90 kg. So what else is there to know about it? Cat, leopard. So the next line can say lives for how many years. So we can say end here. Strange. So I have to go F, and then hit enter. There should be a space here. And lives for. So now we're going to need dot lifespan. Lifespan years. Years. Space, new line character, F string, then enter, and can run at a of. In here, self dot speed in kph. And we can do kph. Alright, let's try this out. The cat weighs 5 kg, lives for 17 years, and can run at the speed of 16 kilometers per hour. The leopard weighs 90 kg. So now you can basically print the cat object or the leopard object, and it looks really cool. So that is the special string method. Now let's have a look at overriding it. So we can literally copy this whole string method, put into leopard, probably put it in after vocalize actually, and then do some modifications to it. Now since leopard is now having this attribute spotted, let's make a comment so that the spotted is included. So you see how it says leopard here? It should either say just the leopard or the spotted leopard. So how can we handle for that? Well, here's an idea. Before the return, you can do an if statement to check if the leopard is spotted, right? So if self dot spotted, I think it's underscore spotted, yeah, because it's protected, double equals to true. Then we can have some sort of an insert, little string, and that can be just a word, spotted. If I'm going to insert it here, maybe I'll need a space. And otherwise, we'll insert nothing, else st is blank. So right here, I'm going to put in the st. I think I'll need a space. If there's a space after, I won't need a space there. So, when I run it, oh, see it's got 2 spaces. Don't know. Run it. The leopard. Okay, so I think I'll need a space after spotted. Now watch this. Remember, the leopard was false for spotted. Now it's going to be true. Watch this. Ha! The spotted leopard weighs. So, there you go. That's an overriding, customized string printing method. So when we print Tommy here, he uses the original one from the cat. Tommy's a cat. The leopard one uses the leopard one. I mean, just for the fun of it, let's put this as false to make sure this works as well. So this should just say the leopard. Yes. All right. So to summarize what we've covered is, first of all, we have overridden the init from the cat for the leopard. We have added an extra attribute which was spotted. Using this super function, we basically inherited mass, lifespan, and speed from cat, so we don't have to basically specify them here. The added spotted was, an added attribute. We then created the string method, which basically prints the object. You could print the actual object and you get a nice little sentence as opposed to what we were doing up until now, was printing the dictionary. And then we overrode that as well to account for the spotted situations with the leopards. Multiple inheritance. Now this is a special feature that Python has and gives you the ability to inherit from more than one class. This is not used often at all, but the most frequent feature is this concept called Mixins. Mixins essentially inherit from class A, attributes and methods, but there's also a second class. The second class is a mixin, and usually the only thing inherited from a mixin are methods. So you can think of an example for if you have a logger class that's writing a log file, you could inherit some special other class that has logging methods that you want to use. So the syntax for this is basically, first comes the superclass 1, superclass 2. Typically you would write your mixin as your superclass 2. And the subclass inherits all the features of both classes. But as I said, a mixin, the idea is you're going for the function. So here's a bit of a diagram. So you have class 1, a child class that inherits from class 1, and you have class 2, which is a mixin, and what you're inheriting from the mixin is, for the most part, methods. At least that is the idea. So let's have a look at a very, very simple example of multiple inheritance where we have class mobile phone, class camera, and we'll bring the features of those two together into class camera phone. In this video, which is the last of our lesson, we are going to just have a very quick look at multiple inheritance. What we have here is a class that makes mobile phone objects. The mobile phone objects don't do anything, they just have memory. So that's like a feature that we're going to inherit from mobile phone. It's an attribute. The attribute is memory. Then there's camera objects that, again, don't do anything, but they have a method to take the picture, so they have a method that we want to inherit. And we want to create a class that's child of them both. So that class could be camera phone. And that can inherit from mobile phone and camera. Inside it, well, we don't have to have anything pass. So we get that space there. So we've inherited from both. Now is the time to basically test the premise that the camera phone is both going to have a memory and an ability to take pictures. So let's try that out. So let's create, iPhone is a camera phone. My phone equals to camera phone, and you put in the memory in creation. And I don't know, let's say it's an early iPhone, 16 GB. So let's test it for memory first. Print iPhone.memory. Run that. Run it here. 16 GB. So far, so good. And let's iPhone.takePicture. Say cheese. So there you have it. That's an example of multiple inheritance. The camera phone class that makes camera phone objects has got the attribute inherited from the mobile phone, which is memory, and it has the method inherited from camera, which is take picture.